will explore this case, the zero launch angle. I'm going to substitute all these values in the fundamental equations for the projectile motion. So this graph shows So in this video we'll explore zero launch angle. Now here you see these two projectiles launched at different angles. Now let me first explain the coordinate system. This is our positive y direction, this is the positive x direction. Similarly this is positive y, positive x. Now here you see that the projectile is launched at some angle above the x-axis. This angle is theta, which is greater than 0. Now here in this case the projectile is launched horizontally, that is the angle between the x-axis and this velocity vector is 0. Here this theta we have 0. So in this video we'll explore this case, the zero launch angle. Next we'll see the equations of motion for this case. So we have this projectile launched with some velocity v0 and let this height be h above the x-axis. Now the initial velocity of the projectile is horizontal, so we can say that v0x, the initial velocity in the x direction is v0, and there is no component of this velocity in the vertical direction, so we can write that v0y is 0. Now the only acceleration is acceleration due to gravity, which is in the downward direction. So ay, this will be minus g, and there is no acceleration in the horizontal, so ax we have 0. Now this is the initial position of the projectile. Now at this position x0 we have 0 and y0 we have equals to h. Now I'm going to substitute all these values in the fundamental equations for the projectile motion to find the equations of motion in this case, right? So we have the fundamental equation x is equals to x0 plus v0x times t plus 1 over 2 times ax t square. Now x0 is 0 here, this will be 0, so from here we'll get x is equals to v0x, we have v0, so this is v0 times t plus, now acceleration in x direction is also 0, so this will also be 0. So this is the first equation of motion that we have got. So at time t the position of the projectile in x direction is given by this equation. Similarly we can find the position in the y direction. So we have the fundamental equation y equals to y0 plus v0y times t plus 1 over 2 times ay times t square. Now y0 we have h here plus, now there is no velocity, initial velocity in the y direction, so this will be 0. Now plus 1 over 2. Now ay we have minus g, so I can write it here minus times g t square. Now next I'll be using another equation, fundamental equation, which is vx is equals to v0x plus ax times t. This is in the x direction, and in y direction we have vy is equals to v0y plus ay times t. Now let's substitute the values. So we have vx is equals to, now v0x is v0 here, so we can write this is v0 plus ax is 0, so no need to write. Now next vy, so vy is equals to v0y is 0, so this term is 0. Ay we have minus g, so minus g and t as it is. Now one more fundamental equation we have, which is vx square is equals to v0x square plus 2 times ax times delta x, and in y direction we have vy square is equals to v0y square plus 2 times ay times delta y. Now let's substitute the values. V naught x, we have V naught, so V naught square, and this is Vx square, plus 2 times ax. Now ax is 0, so this whole term would be 0. Now next, Vy, this will be equals to V naught y is 0 here, so this is 0, and this is minus 2 times g times delta y. So we have derived all the equations of motion for this case from the fundamental equations. Now let's assign some values to this projectile. Let this h be 9.5 meter and let this v naught be 5 meter per second. Now I'll be drawing the graph which will represent how the position of the projectile is varying relative to time. So this graph shows the trajectory of the projectile launched from a height of 9.5 meter above x-axis with a speed of 5 meter per second. Now this is the position of the projectile at time t equals to 0, and here time is 0.2 seconds, and this is the position. Similarly, this is at time t equals to 4 seconds, this is 0.6 seconds, and so on. Now if you observe carefully, in the horizontal direction the projectile travels this much of distance in 0.2 seconds. In another 0.2 seconds it travels this much of distance. Now in another 0.2 seconds it travels this much of distance, then here, then here, then here, and finally here. So we observe that the projectile travels equal distance in equal time in the horizontal direction, or we can say that the horizontal motion is uniform, or we can say that there is no acceleration in the horizontal direction. Now if you observe in the vertical direction, time t equals to 0, the position is here in the vertical direction. At time t equals to 0.4 seconds, the projectile is here, then this is here, and then here, then here, and then here. So in the vertical direction the velocity of the projectile is increasing because acceleration is there, which is a equals to minus g. Therefore we can say that the motion is non-uniform in the vertical direction, or we can say that the vertical motion is accelerated motion. So I hope you have understood this thing. Now let's take an example based on this concept. So this example which is based on the concept that we studied just now. So here it says that a girl skates with a constant speed of 1.30 meter per second and releases a ball from a height of 1.25 meter above the ground. So this is our positive y direction, this is the positive x direction. So it releases the ball from this position, and initially the velocity of the ball will be same as that of the girl, which is 1.30 meter per second. Now what we have to find is, there are three parts. In the A part and in the B part we have to find the position of the ball at time t equals to 0.250 seconds and at time t equals to 0.5 seconds. So first I'll be writing the values. Now initially the ball is at this position, and here the x naught, and here at the initial position x naught we have 0 and y naught we have equals to h, which is equals to 1.25 meter. And initially the velocity in the x direction for the ball is 1.30 meter per second, and there is no velocity in the vertical direction initially, so v naught y, this will be 0 here. Now the only acceleration on the ball is acceleration due to gravity, which is in the downward direction, so ay, this will be equals to minus g, and there is no acceleration of the ball in the horizontal direction, so ax, this will be equals to 0. Now to find the x and y values at this time, I'm going to use the fundamental equation, which is position as a function of time in x and y direction respectively. So in x direction we have x is equals to x naught plus v naught x times t plus 1 over 2 times ax t square, right? Now x naught we have 0, so this term is 0. Now ax is also 0, so this whole term will also 0. So we obtained that x is equals to v naught x times t. This is the first equation. Now next, in the y direction we have y is equals to y naught plus v naught y, this is in the y direction, times t plus 1 over 2 times ay times t square. Now y naught is h here, and v naught y is 0 because there is no velocity for the ball in the vertical direction, so this is 0. And ay we have minus g, so this would be minus 1 over 2 times g times t square. So this is y, and this is our second equation. Now we can solve a and b part very easily. So for the a part, I'm going to substitute t as 0.250 seconds here and v naught as 1.30 meter per second. So x comes out to be as, this is 1.30 meter per second times t is 0.250 seconds. So this value comes out to be as 0.650 meter. So this is the answer for the x value. Now for the y value, we're going to substitute the values here. So h we have 1.25 meter. This is our h value. Now then minus 1 over 2, g is 9.81 meter per second squared, times t is 0.250 and it's squared. So this value comes out to be as 0.943 meter. So this is the answer for the y value for the a part. Now next, we can proceed with the b part. Now in the b part, we have to just take that time is 0.50 seconds, the rest everything is same. So here in place of time, I'm going to put t as 0.5 seconds and here also 0.5 seconds. So let's put the values. So this is x is equals to 1.30 multiplied with 0.5. So this will be 0.650 meter. Similarly, y, this would be 1.25 minus 1 over 2 times 9.81 times this is 0.5 and it's squared. So that value comes out to be as 0.0238 meter. So this is the position of the projectile at time t equals to 0.5 seconds. Now next, in the c part, we need to find the velocity, speed and the direction of the ball at time t equals to 0.500 seconds. Okay, so we can proceed with the c part. Now for the c part, I'm going to use the equation velocity as a function of time. So vx, this will be v naught x plus ax times t. This is the x direction, and in the y direction we have vy equals to v naught y plus ay times t. Now ax is 0, so this whole term is 0. So vx, this will be v naught x, and v naught x we already know it is 1.30 meter per second. So this the velocity in the x direction remains the same because there is no acceleration and there is no drag force. So that is why this velocity remains same. Now in the vertical direction, v naught y, this is 0, ay is minus g times t. G is 9.81 and time that we have to take is 0.500 seconds. So this value comes out to be as minus 4.91 meter per second. So we have obtained the x and y component of velocity at time t equals to 0.5 seconds. Now for speed, it's pretty simple. Speed at this time will be under root the x component square plus the y component square. X component is 1.30 meter per second and it's squared, plus the y component is minus 4.91 meter per second and it's squared. So this value comes out to be as 5.08 meter per second. So this is the speed of the projectile at 0.50 seconds. Now next, we have to find the direction. So let me draw the vector diagram first. This is our Vy and this is our Vx. This is 1.30 meter per second and this is negative 4.91 meter per second. Now theta we have to find. So theta we have tangent inverse Vy over Vx. So tangent inverse Vy we have minus 4.91 divided by Vx we have 1.30. So from here we'll get the direction, basically the theta, to be minus 75.2 degree. And let me represent on the vector diagram also. So this will be our vector v. This is v vector, right? And this angle is 75.2 degrees. And why we got this answer to be negative? Because actually this angle is below the x-axis and we have measured it to be in the clockwise direction, which we always measure in the anti-clockwise direction. That is why this value comes out to be negative. But from this vector diagram we are very much clear that this will be the direction of the velocity of the ball at time t equals to 0.5 seconds, right? Now from this example we can note one thing, that x position of the ball does not depend on the acceleration of the gravity. From this equation we can say that x is a function of v0 times t. It does not depend on the acceleration of the gravity, and the y position does not depend on the initial velocity in the x direction. From this equation we can say it doesn't matter what the value this v0 is. It may be 4.50 meter per second, it may be anything, but this position, the y, does not depend on this initial velocity in the horizontal direction. So with this, I'm going to end this video. So goodbye.